Alright, this is your pre-calculus final exam review. Number 1, for the following triangle, find the indicated side length and select the answer closest to the final answer. Alright, now, since we are trying to find side length, the formula that I'm actually going to use is this one right here. The A with the little a's, little b, and little c on top, because like I said, we're trying to find a side length, and that'll just make it easier. This is the same thing, but normally use these when you're trying to find an angle. That way it puts your inverse sine on top. All right, so we need to find C. So C over the sine of angle C, which I'm gonna go ahead and write in the angle. Now, since this is little c, that means this is big C. So 22.3 equals, now since we also have this pair, I'm going to use it, 63 over the sine of 85.9. Alright, cross multiply. C times the sine of 85.9 over 63. Why did I say over? It equals 63 the sine of 22.3. Now we're going to divide both sides by the sine of 85.9 divided by the sine of 85.9. Now this is a straight type it into your calculator problem. 63 times the sine of 22.3 divided by the sine of 85.9. And this comes out to 24 degrees. Now if you notice it says rounded to the nearest whole number. This is your only answer, rounded to the nearest whole number. Alright. But that's how you do that one. That's just law of sines. Not bad, not bad. Just law of sines. Alright, number 2. Now, on this one it says, for the following triangle, find the angle shown in the picture. You can choose whichever lettering you wish. Now, you see how this is A equals the inverse cosine of B squared plus C squared minus A squared, and then there's no A in the bottom? That means this will have to be angle A, and then B and C, it doesn't really matter. Okay? And then this here is going to have to be little a. Otherwise, it doesn't matter. So A equals the inverse cosine of 52 squared plus 27 squared minus 73 squared divided by 2 times B times C. Alright, now I'm just going to simply straight plug this into the calculator. 52 squared plus 27 squared minus 73 squared over 2 times 52 times 27. Alright, this here, it gave me a fraction, which is fine, negative 79 over 117. Well, sorry, that's what the parentheses equals. So now we're going to do the inverse cosine of the negative 79 over 117. Okay, so inverse cosine of that, and it says rounded to the nearest whole number, so it looks like it's going to be 133 degrees. Okay, now remember, the parentheses equals the 71. Okay, not the whole thing. This parentheses, it's negative 79 over 117, so then we took the inverse cosine of that, and that will give us A. Alright, just remember, this says A equals, and then, so this letter here and this letter here should agree with each other. And then, whatever this letter is the angle that you're going to be finding. Okay, so in this case, our angle that we're finding is going to have to be A, and the 73 is going to have to be little a. Alright, next one, number 3. Alright, for this one here, we're not going to need this first formula because we have sigma notation. If we didn't have sigma notation, we'd need to use it. But since we have sigma, we don't need to use that. Alright, so we need our first term and our second term. So to get our first term, you just simply plug this number in for j. or whatever variable. So a sub 1 is going to equal 1 plus 2 times 1, which is simply 1 plus 2, which is 3. And then a sub n, which is our last term, we're just going to take the 59 and plug it in. So it's going to be 1 plus 59, whoops, 2 times 59. And then 2 times 59 is 118. So it's going to be 1 plus 118, which is 119. And now n. Okay, now we got to find n. N, if this number is 1, n is simply your top number. But if this is any other number but 1, what you're going to have to do, you're going to take the top number minus the bottom number, and then you're going to add 1. So as you can see here, you can see why if this number is 1, it comes out to be just this top number, because you're going to subtract 1 and add 1. Okay, but if this wasn't, say this was 0, you'd do 59 minus 0, which is 59, plus 1, which would be 60, and you'd actually have 60 terms if this was j equals 0. Alright, so now let's plug this in. 3 plus 119 times 59 over 2, and that's going to be, and this is going to be 122 times 29.5, which comes out to 33,599. All right. So again, we just used this formula, and we found a sub 1 by just plugging in the bottom number for j, and we found a sub n by plugging in the top number for j. We added those together. We found the number of terms by taking the top term, subtracting 1, and then adding 1 to that number, or just using the top term because it starts at 1. And we got 3 plus 319 times 59 over 2, which is 122 times 29.5, which equals the 3599. All right. Now let's go on to number 4. Number 4, we're gonna use the second formula as well. We don't need the first one again for the same reason, because we have sigma notation. A sub 1 we're going to find the same way. Plug 1 in for the variable. So a sub 1 equals negative 5, 1/2 raised to the first power, which is simply negative 5/2. Now if you notice here, we don't need a sub n, we just need r and then the number of terms. R is simply what's in the parentheses. That's it, what is in the parentheses, okay? So the sum is going to equal negative 5/2 times 1 minus 1/2 raised to the 7th, because remember, if this is 1, you just take the top number for n, over 1 minus 1/2. Okay? 1/2 raised to the 7th is 1 over 128. So this is going to be negative 5/2 times 1 minus 1 over 128 over 1/2, because that's 1 minus 1/2. Now I'm just simply going to calculator this. Okay, negative 5/2, open parentheses, 1 minus 1 over 128. Oops, do that again. Negative 5/2, 1 minus 1 over 128 over 1/2. And this is going to come out to, let me get the decimal, negative 4.961. Again, you can just stick this into the calculator here and just go from there. Okay, and that's all there is to that one. Remember, we just use this formula. A sub 1 we found like up here. You plug 1 in for the variable and solve for it, negative 5/2. R is simply what is in the parentheses, and n, you find n the same way for both of these. If this starts at 1, it's simply the top number, but if this does not start at 1, it's the top number minus the bottom number, and then you add 1. Alright, let's go to 5, and we're going to be halfway done. Alright, major axis, identify the center, major axis direction, and minor axis direction, and both semi-major and semi-minor lengths. Alright, so remember your center point is simply hk. Alright, and if you remember your equation here, it's x minus h squared plus y minus k squared. Okay, so since this is x plus 1, that means h has to be negative 1, so that rules that one out. Since this is y minus 4, that means it has to be a positive 4. Okay, so our center is negative 1, 4. Well, all we can roll out is c. Now, this 49 here is a squared, and this 25 is b squared. Alright, so a is simply the square root of 49, which is 7, and b is the square root of 25, which is 5. Okay? Now, since a is larger than b, that means x is your major axis. So we can roll out this one. Okay, that means x is your major axis. My pen stopped writing. Now, and then your major axis length is going to be the 7. Okay, so the answer is going to be D. So your major axis is x, your minor is y, your major axis length is 7, and your minor is 5. And the reason we knew the x was the major was because A is larger than B. Okay, that's how we knew that. A was larger than B. Alright, we're halfway there. Number 6, identify the center, transverse axis direction, and transverse axis radius for the following hyperbola. Alright, so this one's going to be similar to the last problem. Alright, our center point is still HK. So here we have we're going to have x minus negative 4, so x is negative 4, and since there's nothing by y, it is simply 0. So we can roll out this one, and we can roll out this one. Now, transverse axis direction. Since y is first, your transverse axis direction is y. Okay? And then your radius is simply, since this is, actually in this case it's b squared because it's with y. Since this is b squared, b is simply the square root of that, which is 8, which gives you your radius. Okay, so number 6 is C. Number 6 is C. Alright, and now it's just using the equation. Found our center point, HK, and we rolled out 2 of the answers based on that alone, and then since B is larger than A, that means our t-axis is the y-axis, and the radius is simply B. Okay. Number 7, find the unit vector version of vector 7, 8. So the first thing we got to do here is we got to find the magnitude. Well, the magnitude is simply 7 squared plus 8 squared, which is the square root of 49 plus 64, which is the square root of 113. So now our unit vector is, you can write this one of 2 ways, because the square root of 113 does not reduce down. You could literally give me 7 over the square root of 113, comma 8 over the square root of 113. Or you could simply give me the decimal of that, which is going to be 0.659, comma 0.753. Alright, I'll take either answer there. Alright, so we found the magnitude. Then you simply take your x component divided by the magnitude, take the b component divided by the magnitude. So we use this formula and this formula. Okay, that's all you got to do there. Now the angle between 2 vectors, we're going to use this formula here. We're going to do the dot product. Remember, the dot product is simply you multiply the a's together, you multiply the b's together, and then you add the numbers together. So our dot product is going to be 4 times negative 6, which is negative 24, plus negative 1 times negative 5, which is 5. So that's going to give us, what, negative 19. And so let's see, negative 19 over, now it's the product of their magnitudes. So this one is going to be 4 squared plus 1 squared, which is going to be the square root of 17. This one here is going to be 6 squared plus 5 squared, which is 36 plus 25, which is the square root of 61. Alright, so now this is going to be the square root of 17 times the square root of 61. So altogether it's going to be negative 19 over 32.202. And now we're just going to do the inverse cosine of this here. Okay, so inverse cosine of negative 19, and I'm going to put this back as the square root of 17 times the square root of 61, because we can type it into the calculator just like that. Alright, so negative 19 over the square root of 17 times the square root of 61, and it comes out to 126.2 degrees. So where are we at? Bingo, letter A, 126.2 degrees. Alright, so again, we just simply use this formula, dot product, right here. Whoops, I was supposed to circle that. The dot product is right there, negative 25, because you just multiply the a's together. So 4 times negative 6 is negative 24, plus negative 1 times negative 5 is positive 5. So negative 24 plus 5 is negative 19. And then you're going to divide by the product of the magnitudes. The magnitude of the first one is the square root of 17. The magnitude of the second one is the square root of 61. So now we're simply going to do the inverse cosine of negative 19 over the square root of 17 times the square root of 61 to get 126.2. All right, that's all there is to that one. Number 9, we're going to convert from polar to rectangular. All right, polar to rectangular. So x equals r cosine alpha. So x equals negative 2 times the cosine of negative 140 degrees. And then y is simply negative 2 times the sine of negative 140 degrees. All right, so just punch that in the calculator, negative 2 cosine negative 140. So x is going to be 1.532. So that rules out that one, that one, and that one. So the answer is going to be C, but let's just figure out why, just for kicks and giggles. It is 1.286. So that just confirms it. Alright, all we did was use these formulas here that were given to you. Remember, this is r and this is alpha. So x is simply r cosine alpha and y is simply r sine alpha. So negative 2 cosine negative 140 gives you x, and negative 2 sine of negative 140 gives you y. Alright, let's move on to the last one. Number 10, we're converting from rectangular to polar. Now, before we get started, what we're going to have to do is we're going to have to check this when we're done. Okay? Because here's our coordinate, negative 1, 5. So we need to make sure when we get done, we're going to be able to hit that coordinate right there. All right? So alpha is simply the inverse tangent of y over x, which is going to be negative 5 over 1, or just simply the inverse tangent of negative 5, which that gives us negative 78.69. And then r is simply the square root of 1 squared plus 5 squared, which is the square root of 26. All right, now negative 78.9. That's going to get us down here. So we're going to have an angle that's down here somewhere. All right. Now, if we do a positive radius, what that means is since our angle is in the fourth quadrant, when we start at the origin, we're going to go square root of 26 in the direction of our angle that we just found here. So which means our point is going to be down here. But we want our point up here. Okay, we want our point up here. So that means we're going to have to use a negative radius to get up to that point. Okay, because we're going backwards from where our angle is. Our angle is in the fourth quadrant. We're going backwards from that to make our point in the second quadrant. So we're going to have to use a negative radius. So therefore, our answer is going to have to be negative 5.099 and negative 78.69 degrees. Okay. For number 10, the biggest thing you're going to have to worry about is making sure that your polar coordinate and your rectangular coordinate agree. Okay, when you go from polar to rectangular, it comes out in the wash, so to speak, so you don't really have to double check it. But when you go from rectangular to polar, like in number 10, you always have to check your answer to make sure that both sets of coordinates point to the same point. All right, and again, since we're using an angle of negative 78.69 degrees, and we need to hit a point in the second quadrant, that means our radius is going to have to be negative. Radius has to be negative in order to land in the second quadrant. All right, because remember, positive radius goes toward your angle, this is our angle. A negative radius points the opposite direction of your angle, and that's what we want in this case. All right, so that's been your final exam review. Feel free to watch this as many times as you need to, and make sure when you come to class, you're ready to take the final. Good luck.